Angular signals are reactive primitives for Angular applications. They provide a simpler and more straightforward syntax than RxJS, the standalone JavaScript reactive programming library. Let's take a look. Welcome everyone. Angular Signals was introduced in Angular version 16. We take a look at my version. Now I have the 16.2.0. Cool. So I will create a new Angular application, ng new signals. Angular signals can either be writable or read-only. Let's take a look at writable signals. To create one, let's use the signal and pass a default value. I will create an object with two properties, value and isActive. I created a new signal as in a default value. In the HTML, I will delete all the default HTML. I will add a new tag to show the actual value of the signal. I will pass the corresponding value. A signal's value is read through a getter function. I will type insert and add the flag. I have to pass the value or writable signal, that value. The initial value that it's 0. Cool. A writable signal provides an interface to update the signal's value and with methods like set, update, and mutate. Also contains a method to create a read-only version of the signal. To test these functions, let's create a new input, and the value will be the writable signal, that value. I will use the change method to change the signal value. So let me add this method. I will call the writable signal that set will pass a new value from the input field, and the isActive will be true. Let me save. I would change the value to 15. The second method is update. This method uses the current value of the signal. I will add a new button and add a click event. I will subtract signal, subtract writable signal value. We'll create the corresponding method. Writable signal that update will use the current signal value. I will use this subtract signal, and a button is not a test. This type property from the input. So here we can use this spinner. Here I'm using the update based on the current signal's value. Perfect. The last writable signal method is mutate. This is why I'm using an object. With the mutate method, we can update just one or more properties from this object without changing the reference type of the signal's object. So to do that, I will use two buttons, one to enable and one to disable the signal's value. Let me move this to the button at a title, signals. Here I will add two buttons. I will use ngIf to show the enable button when the writable signal is disabled, called the isActive property, and another button when the writable signal is active. Let me use the name of the new method and call writable signal that mutate. I'll just update the isActive property equal to the opposite. I will use the isActive property to disable this subtract signal functionality when a writable signal is not active. Let's take a look. Okay, so I get the function, sorry. I have the input writable signal value. Let me subtract and disable the writable signal. Cool. So every time I'm updating the signal from the input, it will enable the signal again. Just click this button, it will mutate by changing the isActive property to the negative. So at the moment, we're using the three methods provided by the writable signal interface to update the signal's value. Here it's important to remind that a signal is a reactive approach that contains a value and notify consumers when this value changes. It's based on the observed pattern. The second type of signals are called computed signals. So I will create a new computed signal. By calling the computed function, we can create computed signals based on conditions. Computed signals are derived signals. It's a dependent lazy signal that will be recomputed when the dependent signals are updated. These signals are memoized because once calculated, the signal value is cached to prevent recalculation. I will create a condition based on the dependent signal, in this case, the writable signal that we've created. If the isActive value is 2, I will multiply by 2 the writable signal. Otherwise, I will return 0. Let me import from Angular code. Here in the HTML, I will show the new computed signal value, and I will call the computed signal. Let's see what happened. So we'll update. As you can see, the computed signal is multiplied by 2. I will disable, and automatically the computed signal value is 0 because this computed signal is based on conditions. We've started writable and computed signals. Now I will mention an operation used in Signal called effects. It's useful for logging, debugging, or analytics by tracking Signal's value. Here I will create a constructor and use the effect function by logging the product of both signals. Writable signal that value times computed signal. Cool. First value is 0. Here we have the signals product. 3 times 6 is equal to 18. Perfect. Now, how to implement the same code with RxJS? We will create a new observable to pass an initial value, an object value 0 and is added equal to true. Let's add a new computed observable based on the new observable created with a map operator to emit a new observable value. So here I will just add a condition similar to the computed signal condition. Cool. Let's spend in the HTML. I will use the async type to subscribe automatically on the observable. The same way for the computed observable value, and we add a parenthesis and print the value. Okay, at the moment I haven't emitted different values from the observables. To change the current value of the observable, I will emit a new value by using the next function. So value will be event that target that value is set it remains true. Similar to the date, I will use same next function. I will obtain the current emitted value from the observable by using the getValue function. And finally, for the enable disabled signal, I will pass the current using the spread operator, and isAdded will be the opposite. Let's see what happened. As you see, the observable value now is 23 and the computed is multiplied by 2. Let's disable the signal, and as you can see, the computed observable value is 0 because it's based on the same condition that we wrote for the computed signal. Perfect. Finally, let's use an RxJS-Interop Library to convert signals to observables and vice versa. Let me type writable signal that as read-only. It will create a read-only copy of the writable signal property, so it cannot be changed. And a new property signal to observable, just to initialize here the observable of type number. Let me import the observable and to signal functions. Nice. So here to signal will be to signal the observable. This to signal function returns a signal of type T or undefined. I will cast this transformation. Will import from Angular code. So far so good. And signal to observable, we'll use the to observable function and pass it the computed signal. Now in the HTML, the signal, I will use the async pipe computed signal to observable value, and the observable value to computed signal is to signal that value. Here we go. Okay, let me modify the name. You can see it's automatically updated the computed signal to observable value, observable value to computed signal. So cool. Maybe you're wondering why the observable value is changing if we're not emitting a new value. And here comes a powerful functionality from this to observable function. The description says that the signal's value will be propagated into the observable subscribers using an event. It's so powerful because whenever the computed signal is updated and the observable emits a new value based on this signal's value. But be careful. Signals and RxJS are different. It's not a replacement. With signals, no subscriptions are needed. They are automatically destroyed, like the async pipe for observables. Signals aim to improve the change detection system for Angular applications, like the on-post change detection strategy. Signals are only synchronous, ideal for managing state. RxJS is especially for asynchronous data using observables, emitted items that can be observed over time. If you want to learn more, don't forget to subscribe. May the code be with you.